Lesson six, application of linear equations and inequalities. This is going to be kind of summarizing everything we've done in topic A, talking about discrete versus continuous information, inequalities, and equations in two variables. So we're going to start with a video. Now, I can't get the sound to work on this, so you will just have to enjoy it as it is. So we're looking for the important information from this video, which is obviously the prices here. Burritos cost $3.50. Tacos cost $2. And her goal today is to make at least $120. Start thinking about what inequality symbol you would use to represent at least $120. So again, making sure you got that important information from the video, the price of a taco, the price of a burrito, and her goal, Nina's goal. For number 1 through 3, let me give you a quick example of each of these. So number 1 wants combination of tacos that will be more than $120. So tacos and burritos. So if burritos are $3.50, tacos are $2. We can figure out 170. If we get 20 burritos and 50 tacos, that's $170. So that would be more. For number 2, it wants to be exactly $200. So same prices. We get, or exactly $120. 20 burritos and 25 tacos gives you exactly $120. And one that will be less than $120. If we get 50 tacos but only 5 burritos, it gives us $117.50. So that one works. Come up with 2 more on your own for numbers 1 through 3. Pause the video so you can do that, and then keep going when you've got that. All right, so once you have that, you're going to plot those points on the coordinate plane. If you noticed, I had little things here. So getting 3 colored pencils and doing a check mark of one color for number 1. That means, yeah, that would get her more than her goal. A solid dot in another color for it would be exactly 120. Think about if that meets her goal. And then a different color and X for the ones that will earn her less than 120. So with the 3 that I gave you, this is what mine is looking like. Go ahead and plot yours, keeping in mind that these are being measured by units of 5. All right, so now for number 5, we're going to start by defining our variables, and then you're going to write an inequality, a linear inequality. That's those 2 variables. Um, and so we have, it's already given us that X is the number of burritos because that's on our X-axis, and Y is the number of tacos because they put that on our Y-axis. So what would your inequality be for this one? So for number 6 and 7, I don't know why it gives you a whole page for each of these, but number 6 is to graph the boundary line, which you might have already done. But remember that our boundary line is going to be if we rewrote it as an equation instead of an inequality. So 3.5x plus 2y equals 120. And then you can go ahead and find your, this is in standard form, so either convert it to slope-intercept form or use this to find your y-intercept and your x-intercept. So your boundary line will look something like this. I went with a solid line because of course that includes that equal to. So you should have a boundary line that looks something like this. Now it's not perfect, but you should see any points that you had from number 2 should be on that line because those are the ones where it equaled. And then for number 6 is graphing the solution set for it in the coordinate plane. So that is of course figuring out which side, which half plane should be shaded. And if you marked 1 and 3, 1 is the ones in which she is making more than $120. So those are the ones that are on the side that is shaded. So I think that makes it pretty obvious that you should be shading this side. So now you have your graph, and we have a couple questions to ask. So is the ordered pair 1049.5 a solution in this context? Why or why not? I've started it out for you. You just need to tell me yes or no. And then for number 9, does shading the half plane in problem 7 accurately represent the graph of the solution set? Why or why not? So think about this is, I'm even gonna give it to you, this blank that we have right here is going to be either discrete or continuous. So think to yourself, if I am talking about somebody buying tacos and burritos, would that be discrete or continuous? All right, the last thing we're going to do together here, number 10 and 11. So we have a set of two numbers that have a sum less than 5. So remember, sum is addition. And for number 11, it's two integers that have a sum less than 11. Integers, of course, meaning numbers that are not decimals or fractions. So come up with on your own, find 4 solutions and write the inequality yourself. And once you have that, we will go on and talk about how you graph these. All right, I'm not going to give you answers for this first part that you did on your own, but something to note is that your inequality looks more or less the same, even though one of them is integers, right? You're still going to do x plus y is less than 5, but what looks different is going to be the graph. So on the left-hand side here, where it was any number, you see that I've just kind of shaded it in. Whereas on the right, when it had to be integers, I've put individual points on this to cover the spots that it can be, because it has to be an integer. So it has to be exactly on the grid. That is obviously obnoxious. And we don't actually expect you to do that when you are doing a discrete solution set. So that, of course, means that for this first one, the solution set is continuous because any ordered pair in the half plane could be a solution. And for the second one, the solution set is discrete because only coordinates that are integers can be a solution. So making sure you have those written down. And the real expectation when you're doing this is just when you are doing your solution set, just like when we would do it for anything else, you define that exact solution set. So for number 10 here, the solution set would be ordered pair x, y, such that x plus y is less than 5. And that's your entire solution set. Whereas on number 11, your solution set is x, y, such that x plus y is less than 5, and x and y are integers. Again, like I said, we don't really expect you to do all these individual dots. That's crazy. So you can just shade it in like this and then have a note at the bottom of your graph that says something like the solution set only includes integers. And that would be good. Or any other qualifications. If we're talking about the tacos and burritos from the top of this, our solution set, here, I'll shade this in. But we'd say the solution set only includes integers. And the other qualifying is that they have to be positive integers because we can't buy negative tacos. So only includes integers greater than or equal to 0. The last part of this lesson is kind of a choose your own adventure. You will notice there are just so many pages of work. I just need you to pick 2 of these. So there are 3 different scenarios. Problem 12, 13, and 14. Pick 2 of those to do on your own. And that is going to be the end of the lesson.